In this video, we're going to take a look at testing for one variance. In our question it reads, a coffee machine is supposed to dispense 6 fluid ounces of coffee into a paper cup. In reality, the amounts dispensed vary from cup to cup. However, if the machine is working properly, most of the cups will contain within 10% of the advertised 6 fluid ounces. In other words, the standard deviation of the amounts dispensed should be less than 0.2 fluid ounces. A random sample of 15 cups provided the following data in fluid ounces. At the 5% significance level, does the data provide sufficient evidence to conclude that the standard deviation of the amounts being dispensed is less than 0.2 fluid ounces? And it says that S is equal to 0.154. Now the S is the standard deviation of the sample, and we have 15 cups. So let's go through and highlight all the important information. We have a standard deviation of 0.02, that's our population standard deviation. We have an N equal to 15. We're using a 5% significance level. And we have an S, 0.154. And here in this question it asks to conclude that the standard deviation of the amounts being dispensed is less than. We're going to test for variance. So here we want to know if it's less than, so we have a left-tailed test. That's important as well. So if we know that our standard deviation is equal to 0.2, then our variance is equal to 0.2 squared, or 0.04. So our null and alternative hypothesis are going to be, alternative hypothesis, we're looking for less than, so we're left-tailed, so we're going to say that sigma squared is less than 0.04. And for our null hypothesis, sigma squared is greater than or equal to 0.04. And now we need our critical values. And when we're doing a test for one variance, we're using chi-squared distribution. And now we want to find our critical value. And we're doing a left-tailed test. So we have chi-squared critical, and we're going to use the left side. And that's going to be equal to, and we go to our chart, and we go across. Now, the one thing that's different about the chi-squared versus the z-chart is, if you notice, it reads right. So if we want a 5% significance test on this side here, and we want this area to be 0.05, then we need to look at the remainder, which is 0.95. So we're going to go across to 0.95 and then down to degrees of freedom. And our N was 15. So our degrees of freedom is N minus 1, or 14. So we go down to 14, and we find that it's 6.571. So we're going to reject H naught if chi-squared calc is less than 6.571, and now we want to find our calculated value, so we're going to do chi-squared calc, and that is equal to N minus 1 times S squared divided by sigma squared. And our N minus 1 was 14, that was our degrees of freedom. S was equal to 0.145, and we're going to square it, divided by sigma squared, which was 0.04. And when we put this in our calculator, we get 8.295, which is not less than 6.571. So we're going to fail to reject H naught, and now we need to write our conclusion. And our conclusion is, at the 5% significance level, there is insufficient evidence to conclude that the variance is less than 0.04 fluid ounces. And that's our video on testing for one variance.